Okay, geometry students, I hope you are having a good weekend. These are the notes for Monday, November the 11th, and we have a couple more of the congruence postulates to look at on triangles. So let's get to it. Our objective for today, much the same as it was for Friday, the student will apply more triangle congruence postulates to tell if pairs of triangles are congruent or not. Again, the date for these notes will be Monday, November the 4th. As always, press pause anytime you need more time and hit play when you're ready to move on. These notes should not be any more to write down today than they were the other day, but the length of these may be a little bit the same because there's an extra something that we have to take a look at along the way. All right, now, as you may remember, the two postulates we looked at on Friday dealt largely with side lengths. There was the side congruence postulate and also the side angle side congruence postulate. So they dealt more with side lengths than they did with angle measurements. The ones we're looking at today deal more with angles than they do with sides. So let's have a look. Okay, the angle side angle congruence postulate. Well, reading the name, you can probably guess exactly what it's looking for and exactly what order it's looking for it in. Angle side angle says if two angles of one triangle are congruent to two angles of a second triangle and the included sides, which of course is the sides between them, are also congruent, then the triangles are congruent. Okay, so as you can probably guess based upon the information you're looking at there in the title, angle side angle, we do not need to know anything about the third set of angles, and there are two sets of sides that will not need to be known either. Okay, so if you'd like a little diagram to go along with angle side angle, here's what it's going to look like. And when you follow the name of the postulate, it'll tell you what it's looking for and the order it's looking in: a set of angles, then a set of sides, then a set of angles. Okay, so you've got like the one angle congruency mark near vertex A and D, and then you've got the tick marks along the line segments between A and B and between D and E, and then you've got the double angle congruency mark near vertex B and E. So an angle, set of angles, then a set of sides, then a set of angles. If you can find that in a problem dealing with triangles, then you would be able to say that triangle ABC is congruent to triangle DEF. And as always, if you are going to use one of the shortcut postulates, you have to identify which one you used. Otherwise, you're going to have to prove that all of your sides are congruent and all of your angles are congruent. So this one, triangle ABC, is congruent to triangle DEF by angle side angle. And yes, you can abbreviate it ASA. The other one that we're looking at today that deals with more angles than it does sides is angle side. Okay. Now, as you can probably guess, the only thing that is different between the angle side angle and angle side is the order of the information that we have. Okay, so this one wants a set of angles, then a second set of angles, then a set of sides in that order. So if two angles of one triangle are congruent to two angles of a second triangle, and a non-included side is congruent to its corresponding side, then the triangles are congruent. And just like with angle side angle, we will not need to know anything about the other set of angles, nor will we need to know anything about the other two remaining sets of sides. Here's a diagram to go along with angle side. And as you can easily see, the difference is the one set of sides that we do know, it is not positioned in between the two sets of angles that we do know. This time it's positioned elsewhere, so it's not included. And if you can find these set of conditions inside of a pair of triangles, then you can say that you have two congruent triangles. In this case, triangle ABC is congruent to triangle DEF by angle side. Now, there is one hazard I'd like to warn you away from. People tend to get a little carried away with the angle postulates here, we kind of fall into the trap of thinking, oh, well, you know, any triangles that I can find, if I can simply find three pieces of information and prove that I have three of this, whatever it is, these two sides, that one angle, these two angles, that one side, we get carried away and we start thinking I can prove any triangles to be congruent if I can come up with any information imaginable. And there is one situation that is absolutely a no-no that we're going to have to stay away from. And let's take a look at it here for just a moment. Okay, you need to be aware that there is no such thing as an angle side-side congruence postulate. Okay. Now there's a little bit of a joke hiding in this, and some of you may be able to imagine what it is already, and we'll get to that later on. Okay, but if you're already spotting the joke is not the reason why we do not use something like an angle side-side congruence postulate. We don't use it simply because it does not actually work as far as proving two triangles to be congruent to each other. Okay, so I'm going to start you off with an example. Okay, here is a triangle. Obviously, we have an angle, an acute angle on the lower left side, 20 degrees. We've got a bottom side of 10 and an upper right side of 4. Now, just for the record, this triangle is drawn completely to scale. That angle is actually 20 degrees. This side length is actually 10 units, and the other side length is actually 4 units. So it hasn't been estimated, or it's not just some random triangle that's thrown up there with some random numbers. Okay, this triangle is to scale, and the measurements are accurate. Okay, now, if we were going to say that this triangle was going to be congruent to another triangle, okay, now clearly this triangle would be congruent to any triangle that is identical to itself. However, if we were trying to say that this triangle were congruent to another triangle by this fictitious angle side-side idea, okay, then what you're ultimately saying here is if you're going to say triangle 1 is congruent to triangle 2 by angle side-side, then what you have said is that there is no way that they cannot be congruent. They must be identical if they obey an angle side-side relationship. Okay, so what we're going to do now is we're going to consider another triangle. Okay, here is another triangle. And this one is also drawn exactly to scale. The angle at the lower left is 20 degrees. The side length at the bottom is 10 units. The side length at the right is 4 units. It has the same information in the same basic locations within the triangle as the original one did, but you can clearly see that the triangles are not congruent. And just for a good visual reference, here I've copied both of the triangles, dropped them on top of each other, and you can see the red triangle from above and the blue triangle hiding behind there, okay, that they are not congruent. Okay, well, it's fine. I mean, triangles do not have to be congruent to each other. But the purpose of me taking your time and your paper to do this is to prove to you, here you have two triangles. Do they have a set of angles congruent? Yes. Then do they have a set of sides congruent? Yes. Then do they have another set of sides congruent? Yes. Does that mean that the triangles are congruent, or are they still different from each other? Well, they're very, very clearly still different from each other. Okay, for this reason, okay, we have to make sure that we stay away from this fictitious angle side-side idea. Okay, and I always tell you, you can use the abbreviations and the joke. If you did not get it at the beginning, perhaps you'll get it now. Okay, I've said that you can use abbreviations like SSS for side, 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 or SAS for side, angle, side. Well, if you find yourself using the abbreviations on a problem, and you are going to answer a question where you say that, yes, I think these triangles are congruent by ASS. Well, there's an unfortunate spelling using the letters ASS in that order. Okay, and hopefully you will make a mental note that if you ever happen to come across that spelling, that something has just gone wrong. And again, we're not staying away from this because it spells a word that we'd rather not use. We're staying away from this because, as the triangles above demonstrate, it simply does not work. Okay, the 4 shortcuts that I gave you are the 4 shortcuts that will work. Okay, so let's take a look at some examples just like we did for Friday. Here are 5 sets of triangles. We're going to see if we can talk our way through them and figure out which ones may be congruent by the rules that we are discussing, or possibly maybe even the rules from last Friday, or which ones we are lacking enough information to be able to say that they are congruent or not. Okay. So as you are copying them down, I'm going to begin walking through them. Let's start with the one at the top left. Okay, obviously we have 2 right triangles. That is a set of angles. We have 1 set of angles congruent. Obviously we have the tick marks in there, so we have a set of sides congruent. Is there any other information that we can extract from this problem? I think there's another set of angles that you can get. What about these guys? There and there. Are those going to be congruent? Yes, they will. What type of angles are those? Those are vertical angles. Vertical angles are always going to be congruent. So we have a second set of angles. So let's see what we have here. We have a set of angles, and then a second set of angles, and then a set of sides. Set of angles, another set of angles, and a set of sides. Angle, angle, side. We can say yes. That was terrible. I tried to write yes and messed it all up. Yes, by, angle, angle, side. And as was the case on Friday, if you do not identify that you use this particular shortcut, or you identify an incorrect shortcut, you may be incorrect based upon whatever information is available in the picture. Okay, how about the ones at the upper right? Okay, obviously we have 1 set of angles congruent. We have 1 set of sides congruent. Okay, that's not enough information. What else do we have? I can't see anything else in the picture. We have right triangles. We could use the Pythagorean theorem if we had a second set of side lengths to work with, but we do not. We cannot say that these angles here and here are congruent to each other. We don't have any rule that goes along with them. They are not vertical. I don't see anything that can help us out any further. I think we're probably going to have to say not on that set of triangles. Doesn't mean that they are not congruent, simply means that we lack the information to be able to say, yes, they definitely are. How about the one underneath it? The one in the middle on the right with all the parallel markers. Okay. Now, obviously, we have a lot of parallel lines going on in there. And in between those parallel lines, we have a lot of lines connecting stuff. Those are transversals. Okay, so we have all kinds of parallel lines. We have all kinds of transversals. That means corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, all that stuff is fair game. So let's see if we can figure some things out. Now, obviously, let's start with the first step. Okay, this line segment right through here, it is the same line segment for both triangles. So that one is definitely congruent. We have 1 set of congruent sides. Now the line segment that I just drew in, okay, how about we let that guy be a transversal? And here are a couple of parallel lines that our transversal is connecting. Okay. If we have 2 sets or a set of parallel lines, transversal connecting, what type of angles are these guys that I just dotted right there? They are on opposite sides of the transversal. They are on the interior space between the 2 parallel lines. That makes them alternate interior angles. And alternate interior angles are always congruent if the lines are parallel. The lines are parallel. That means our alternate interior angles are congruent. So we've got a set of angles, congruent. Okay. Well, let's see. Anything else we can come up with? I think we can. I think we can use this parallel line idea for more than just the green ones. I think we can use it for the blue ones as well. If the red line is a transversal, okay, then what type of angles are the ones that I just double dotted right there? Again, compared to the transversal, they are on opposite sides of the transversal. They are on the interior space between the two lines. Those are alternate interior angles, and the rule still is that alternate interior angles are going to be congruent if the lines are parallel. So follow the information that you have in there. Between the green angles, you have a set of angles. The red side, you have a set of sides. And then the blue angles, you have a set of angles. We can say yes by angle, side, angle. Moving on, how about the shape down at the lower left? Let's see what we have there. I think this one's going to be plenty of reasons we can call this one, these two congruent. First off, just using the information that we have, the set of 1 tick marks, that's a side. Then the angle congruency marks, that's a set of angles. Then the second set, the double tick marks, there's another set of sides. So on this one, we could say yes by side, angle, side. But as you're going to see, sometimes there may be more than one way to get this job done. How about this line segment that separates the two triangles? Is it fair to say that it is congruent to itself, that line segment is the same length in both triangles? Of course. So we could also say that it was congruent by side, side, side. Okay, like I said, these problems are not going to come out and tell you which shortcut you want to use. It'll be up to you to decide what information is in the picture and what can you do with it from there. Okay, so let's check one more. This one at the lower right. Okay, well, we have one set of sides congruent, obviously, with the tick marks. We have one set of angles congruent with the right angles in there. And we do have a second set of sides congruent inside there. Okay. Now, if you look at the information that you do have in the order that you have it, you have a set of angles, then a set of sides, then another set of sides. Angle, side, side. So here's one of those instances where we would definitely not want to say yes by angle, side, side. Okay, there's no such postulate that goes along with that. Again, not because it spells anything goofy, but because it simply does not exist. And that also goes for writing it in reverse. Okay, you cannot say yes by side, side, angle. Again, not because we're worried about the spelling, but because that doesn't actually prove anything. If they are going to be congruent, they're going to be congruent for a different reason. So back to the problem, we have two right triangles. Okay, we also know two sides of these right triangles. Okay, guys, well, this is a basic fundamental property of plugging into an equation. Okay, both of these triangles are right triangles, so they are both going to have to obey the Pythagorean theorem. Well, if we were to force the hypotenuse, the longest side of each of these triangles, okay, it becomes the C. Okay, well, if we plug in the same C value into both of these equations, then obviously that matches. If we plug in one of the legs of the triangle, which is one of the sides that builds the right angle, if we plug that in, which is the same for both triangles, then those values will both match. Okay, now guys, the only thing that's missing from Pythagorean theorem in this case is that side length right there. Okay, now if that side length is the only one that's missing, in other words, A is the same for both equations and C is the same for both equations, then what is going to happen with B in both of these triangles? It's the only missing variable in the equation. It's the same values going into both equations. That is going to force that remaining side length to be congruent. So we actually can say yes, but our reason can be for side, 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 or also now you have side, angle, side. Okay, and you don't have to list them all. Okay, just point being, sometimes you will find more than one can apply at one time. Anyway, sorry the notes ran a little bit long, but of course the last 10 minutes or so of this has been me babbling about those triangles. I appreciate you getting time to get your notes done. We'll see you in class on Monday.